Hello and welcome to Ngwasheng Maths Online Academy. My name is Desmond Ngwasheng. I'm doing another part of examination-based questions. As you can see, this problem, it's very unique, but it's also familiar to the examination. Remember, we are still doing trigonometry, where now I want to indicate another part of cosine rule application that appears in a form of Euclidean geometry. So we are talking trigonometry, but now they add uh, the diagram by means of Euclidean geometry. Remember the circle theorem. When you see circle and triangle whatsoever, we know that there is a dash of Euclidean geometry. But even though that's the case, we have to apply a cosine rule application following the previous lesson that I did. Now, let's carefully look at the diagram and study what we have and make sense of everything. So as you can see, we've got the triangle ABC, the bigger one, and where we also have a triangle of BOC. If it was Euclidean, somebody was going to construct here, but depend on your construction, what is it that you want to achieve? As you can see, the one that says angle at the center is twice angle at the circumference. We can also identify the radius there, where we know radius are equal. In this case, from the center to the arc, OB, it's a radius, OC, it's a radius. So we know what is happening with the radius. That means OB is equals to OC. And we're also given that BC is 15, which is equivalent to AC. Hence, I'm saying this is now Euclidean. But let's just carefully check as to how can we engage cosine rule in this diagram. Here is the thing. They want us to find x. They want us to find x. So how to find x? Let's now focus on, let's be specific. Which triangle are we dealing with? In triangle BOC. That's my focus, triangle BOC. What do I have? I have this angle. I have this side, BC. BC is common because BC is part of the bigger triangle and is also part of the smaller interior triangle as well. So I also count BC as the known side. I know this side. I know that. I know this angle. So far you can identify, what you can visibly see is that we've got the two sides and one angle. What can we apply? But if you look closely, since we know that OB is a radius, that means OB is equals to OC. So if this is 10, that means this one is also 10. So now, if we check now, let's abstract this triangle BOC. So we can be able to see it properly. I have OX, and then C. So that's 10, that's 10, that's 15. Now it's clear. Now it's clear. You can see. It's very much clear that we managed to take out the triangles that we want to work with and write it somewhere so it can be visible. The whole thing that you see here, obviously, is to hide that that triangle, to hide the information that will be easier for you to work with. That is the whole thing. Remember, mathematics is just a mind game. The solution is hidden. Where there's a problem, there's a solution, but it's hidden. So by the moment you manage to abstract that triangle and write it there, now it's visible. It's easier to see what you're dealing with. Now, here is 3 things that we can work with. Previously, we indicated that SOHCAHTOA, SOHCAHTOA, sine rule, and cosine rule. Why am I writing this? 2Ds and 3Ds, they all forever rotate amongst these. It's either we find that we engage SOHCAHTOA versus sine rule, SOHCAHTOA versus cosine rule, or cosine rule directly, or sine rule separately, or SOHCAHTOA separately, depending on the nature of the question. Now, let's work on that. Let's check now between the three. Which one are we using? I know learners, they can attempt many different methods. Anyway, in this case, it's only three. You can check which one can work best. Also, don't forget the properties of all this. Soccer tour, we use it mainly when we are having a right angle triangle. So now I don't see that. So for now, I'll eliminate the use of soccer tour. Sine rule. What do we use sine rule for? We use sine rule if we have two sides, one angle, or if we've got two angle and one side. But here is a different story. I've got three sides and one unknown angle. So definitely I cannot use sine rule still. So definitely I have to use cosine rule. Now, let's now create a suitable formula for cosine rule. Don't forget that under cosine rule, we have these three. This is the three formula under cosine rules that we have. So I need to create my own based on what? Based on the given point. You can see I have BOC. And by this formula, they accommodate a triangle of ABC. So meaning I have to engage or incorporate these vertices BOC, but with the influence of what is known. Now, the point of reference is X, angle X. So X is actually angle O. Angle B is unknown, angle C. And then the sides, BO is actually 10, BC is 15, and then OC is 10 as well. So let's take this and present in one of these. Let's accommodate that. So, but now the first thing first is, what am I looking for? I'm looking for X. So X is angle, which means it's representing one of the. So I will start by saying cos of X. Let's say equals to, this side is supposed to be the side. The side that is opposite angle X, the side that is opposite angle X is actually BC. So I'm creating a formula similar to that using what I have, the vertices that I have, BOC. Now, if BC is my side opposite angle O, which is X, now what about the other? So I'll say now, since I've got a BC, now the remaining, I will say BO squared, meaning is this side, plus CO, which is this side, minus 2 of the very same thing. I limited myself with space. Let me expand that. All right. So in this case now, we already know that. Now the very same thing, I'll say BO times CO and then cos of what? Cos of X. That is the angle that is indicated, point of reference. Now, I created this formula with the influence of the original formula. Remember, it's not always the case that will be given triangle ABC, especially when it comes to application of cosine rule. Now, it's easy. Once you do this, like, you are winning. The moment you manage to create that, you are actually winning. Because what is left here is just pure algebra substitution. What is BC? BC is 15. Put bracket is very important. BO is 10. Another CO is still 10. Remember, according to this triangle is isosceles. Two equal sides. So we know. So it's isosceles. Now, we also have like 10 here for BO, multiplied by 10 again for CO, and then cos of X. Cos X is unknown. Now from here, you can celebrate. Go crazy, do you? Like, okay. So what is 15 squared? We just have to find the result of everything there. Simplify everything. So by so saying, We've got 100 here plus 100 here, minus, this is 2, 10 times 10 is 100 times 2. That's 200. And then we've got cos of x. 15 squared, I think it will be like 225. 225. But let me verify that, because you know, mathematically, we say what? 15 squared. Yeah, that's okay. That's 225. Now, what is remaining here is now to simplify, meaning everything here give us 200 minus 200 cos of x. That side we've got 225. So when you transpose, we're going to say 225 minus 200 is equivalent to negative 200 cos of x. So if there's 200 minus that, we are having, let me see. So we are having 25, a positive 25 cos to negative 200. Hence, I'm saying from here is not a problem. Once you can take this and manage to abstract the triangle, which lead us to this step, and be able to create your own cosine rule using the vertices that we have, then you are winning. Because now from here, this is just pure algebra. So, but furthermore, let's just do that. So we left with cos x, which I'll bring it here. Now the result of this, 125, 25 into 25 goes once, into 200 goes like 8 times. So, okay, let's just say, as a, in a decimal, we'll say that will be 0,125. Yeah. As a decimal, it will be 0,125. Now we have to, because we are looking for x, let's shift cos. And when we shift, we ignore the negative, right? So when we shift, I'm going to say x is equivalent to this, which will give us what? Let's see, because now let me take out my calculator. We are shifting there to the right hand side. We are getting 82,8. I'm getting 82,8 after shifting. Now, you can ask yourself, what happened? We ignore the negative at first. So we can further now indicate we cannot just end there. We ignore the negative, but what does this mean? This takes us back to general equations under trigonometry. Cos is negative on the second quadrant. So second quadrant is where we've got 180 minus, can say 82,8. Obviously, we follow the trigonometric equations general solution. Cos is negative in second quadrant, and second quadrant, that's where we have the reduction of 180 minus. So that's why we have to proceed and write that information. In this case, let me calculate and see what do we get as the final answer. As the final answer, 180 minus 82,8. Okay, I'm having x 97, let me see. Damn. Okay, I cancel that. I couldn't see that. 97,2. Yes. There we go, my good people. That was application of cosine rule in examination. That is exam-based questions, straight from the exam. Those who are familiar with, those who are always doing the past papers, you will be able to see that you did come across something like this. And there are some questions which are following this. But because my lesson was based on cosine rule, I just wanted to end there. I know the very same question when it proceeds, they want us to calculate the size of angle ACB, or also find the area of triangle ABC. So I don't want to engage area rule while we are focusing on cosine rule. Another section is based on the area rule, which I'll do it separately. So comment, like, share if you enjoy this lesson and you want more of this. Please do subscribe there, like, share, and comment. Thank you for watching.